morning, everybody. I want to present my study about congruency memory effect and how can we affect it, modulate it using non-invasive pre-estimation. Memory as a constructive process requires some organizing structure to assemble scattered details into coherent memory, into coherent experience. And it was long been established that existence of prior knowledge to which new information can be related generally enhances memory for that information, for encoding, for retrieval, for memory guided behavior, and so on. We can call this prior knowledge organized like a strong memory like a memory structure representing some complex constructs based on our previous knowledge as a schema. And from the point of view of neuroscience, a schema is a pre-existing network of strongly interconnected cortical representation, which can accelerate memory consolidations for new information which is congruent to this previous knowledge. What happens if this process of reconstruction in memory somehow is impaired? Such an interesting disorder as confabulation is when we product some erroneous memories without awareness of their falsehood. So this confabulation arises due to impairs of reconstruction process when we reconstruct something based on inappropriate schema, which is not related to our general knowledge about ourselves, about the world. It was found that this confabulation may be a result of lesions in medial prefrontal cortex. And also experimental studies shown that this area is very important for congruency-dependent encoding, retrieval, consolidation, memory-guided behavior, and decision-making. But these studies usually used a correlational approach. And we tried to replicate one of the studies using non-invasive brain stimulation to establish a causal role of this area in congruency-dependent memory processes. So this is our study of inspiration. In this study, participants decided about congruency of pair of scene and object. How probably this object can occur in real life with this scene. And also they had a task to remember these pictures, and it was found one of the results of the study was that activity of medial prefrontal cortex increased linearly with the congruency of stimuli, and activity in medial temporal lobe increased with decreased congruency. So our hypothesis was that interference stimulation of this area may modulate schema-dependent memory consolidation and affect memory performance in different tasks. So our first problem with which we faced up was how to reach such a deep area. You see, it's quite deep. And only a few studies stimulated deep frontal and prefrontal areas, first because it's deep and not every coil can reach it. And the second is stimulation in this area is very annoying for participants. They may feel some uncomfortable sensations, or their face can't reach, like their eyebrows twitch and so on. But likely we had a very deep and focused coil, parabolic coil, which allows more deep and focused stimulation than conventional lift coil. You can see on this picture, this is the comparative parameters of magnetic field provided by different types of coils. And you can see that our coil really allows more deep and focused stimulation. But this coil is very novel, and we spent a lot of time to just learn to work with it. To stimulate this area, first we needed to define an individual motor threshold for each participant. And we did it by recording MEPs from the leg muscle, because leg muscle is represented in brain deeper than conventionally used for this purpose hand muscle. you can see the position of electrodes, and for interfering with memory processes, we used continuous theta burst stimulation for a total amount of 20 seconds, which was sometimes annoying for participants, but usually it was normal and they could tolerate. This is the general timeline of our experiment. On the first day, participants came, and participants from experimental group received the continuous theta burst stimulation of our target area, and participants from control group received the sham stimulation, which was delivered by the same coil and the same protocol, but the coil was reversed. It also induced this a bit annoying sensations, but didn't reach the brain. And after stimulation, they performed encoding memory task. They decided about congruency of items. You can see an example of very incongruent pair and very congruent pair. And also they had task to remember all pictures. And on the second day they came to pass two memory tests. First was recognition memory test, whether this object was old or new, did they see it on the day before, and associative memory test. What was the context for items which were judged as old? So we used one-way ANOVA with stimuli congruency and congruency based on subject estimations as within subject variable and type of stimulation as between subject factor. This is our result. Unfortunately, we had a very small sample due to all these technical issues I told before, and we obtained only the strongest effect we expected, which is congruency benefit memory effect. Actually, people really do remember congruent items better. But no significant interaction between type of stimulation and congruency of stimuli were revealed. But pairwise comparison showed that there was a significant difference between performance for incongruent and congruent items only in stimulation condition, but not sham. And we only need to increase our sample to increase the significance of this result. And this is a very important result because it shows that our stimulation was selective for this process. We did really modulate only memory for congruent items, which is crucial to understand the role of intermediate prefrontal cortex in memory process and congruency-dependent memory consolidation. So these trends are consistent with our hypothesis, and these results for me are very encouraging, especially taking, like, we had a very small sample, but already we have a good result. I'd like to thank my supervisor, Professor Figura, and also Anna Spector for her contribution. Thank you for your attention. If you have any questions, I will be happy to answer. Thank you.